Alright, the last topic we're going to look at here in college algebra is solving systems of nonlinear inequalities. And so we're going to use substitution method mostly for solving these. So what we got here is negative x minus 7y equals 50, and then x squared plus y squared equals 100. So the second equation is a circle with radius 10. The other one is a line. And what I want to do is I want to solve for one of the variables. So I think I'm going to solve for x in the top equation. So if I do that, I'm going to add x to both sides and then subtract 50. So there's the subtracting 50, and then the minus 7y, and then I added x to both sides. And then what we're going to do is we're going to go ahead and substitute it into the second equation. Okay. So we're going to substitute in, so we're going to have the negative 50 minus 7y, and then that's going to be quantity squared. So then we're going to go ahead and FOIL that. So 50 times 50 is going to be 2,500. And then you have negative 50 times negative 7, which is going to be 350, and then we're going to do that again, so 350 plus 350 is going to be 700 with a y. And then negative 7y times negative 7y is 49y squared, plus the existing y squared, and that's going to equal 100. Okay, so what we're going to do is we're going to combine like terms. So 49y squared plus y squared is 50y squared, plus 700y. And this is quadratic, so we're going to set it equal to 0. And then we're going to subtract 100 from 2,500 to give us 2,400. Everything is divisible by 50, so 50 divided by 50 is 1, so 1y squared. 700y divided by 50 is going to be 14y, and then 2,400 divided by 50 is going to be 48. This factors into y plus 6 and y plus 8. So that's going to give us y equals negative 6, and then y equals negative 8. So if we substitute those in, we'd substitute them probably into this one here. So negative 50 minus 7 times negative 6, that's going to be positive 42, so that's going to give us negative 8. So that's what our first x value is going to be. Okay, and then the second one, we're going to plug it in the same thing, negative 50 minus 7 times negative 8. 7 times negative 8 is positive 56. That's going to be negative 56, or sorry, it's going to be positive 56 because it's a negative times the negative. And then the difference there will be positive 6, so the x will be positive 6 there. Okay. All right, and then so our solution is negative 8, negative 6, and 6 comma negative 8. And I'm just going to draw a real rough sketch. So you got a circle, and then you got a line that's crossing it in 2 points there. So that's what we're finding is the intersection points there. There's a slightly more accurate picture on your completed notes. So if you want to get a little bit clearer picture, but that's what you're doing there is you're finding where the circle and the line intersect. So we're going to look at 2 more examples of some nonlinear systems of equations. Okay, so let's go to the next one. So we're going to solve x squared plus y squared equals 9, and that's going to be a circle with radius 3 centered at the origin, and y equals x squared minus 9. One of your parent functions, the parabola slid down 2 units. So you can obviously see that y equals x squared minus 9 is already solved for y, so we're going to go ahead and substitute that into the first equation for the y. Okay, we'll plug that right in, and then we'll go ahead and FOIL it out. So x squared times x squared is x to the 4th. X squared times minus 9 twice will be minus 18x squared. Minus 9 times minus 9 is 81, all equal to 9. So then we'll put the x to the 4th out in front. combine like terms, negative 17x squared minus 9 from both sides, and that's going to be 72. Okay, so this one is going to factor into x squared minus 9 and x squared minus 8. And then what we're going to do is we're going to set each equal to 0, and then we're going to use the square root property. So here we're going to get plus and minus 3, and here we're going to get plus and minus, 8 is 4 times 2, so that'll give us 2 root 2. Okay, so that's what's going to go on next here. Alright, so we get x is plus and minus 3, and x is equal to plus and minus the square root of 2. So what I'm going to do is I'm going to plug them into this equation here, and what happens, the plus and minus is going to be gobbled up by the squares. So when we plug in the plus and minus 3, that's going to be 9 minus 9, that's going to be 0. So we're going to get 0 with the first one there. So let's go ahead and move that out of the way. So the y will be 0 there. Okay, and then the second one, y equals plus or minus 2 root 2 squared minus 9. Okay, so when we square the plus and minus, that becomes 4, and then the square root of 2 squared is going to be 2. 4 times 2 is 8, minus 9 is negative 1. So the y coordinate is going to be negative 1. Not plus or minus, just plus 1. Alright. And then what this will look like is, again, it's a circle, and then the parabola is going to intersect it in 2 places. So again, this is just kind of a rough sketch of what you're finding there, but we're just finding where those 2 graphs intersect. Okay, we're going to look at one more example. So we're going to solve x times y equals 5. So that is going to be a reciprocal function. It doesn't look like one right now. And then 5x squared plus y squared equals 30. That's going to be an ellipse. So what we're going to do is we're going to solve the first equation for y. You could solve it for x. Looks like solving for y might be a little bit easier, because when we substitute it in, we'll have not as messy of a thing to do. So we'll have 5x squared plus 5 over x quantity squared equals 30. So we'll go ahead and we have 5x squared plus 25 over x squared equals 30. And we'll clear the fraction by multiplying by x squared. So we'll have 5x to the 4th. And then what we're going to do is we're going to go ahead and subtract 30x squared, so that we're being efficient with our space here. Minus 30x squared plus 25 equals 0. Everybody is divisible by 5, so we'll go ahead and divide everybody by 5. And then this gives us a fairly nice problem to factor here. So then x squared minus 5 and x squared minus 1. So then we're going to be taking the square roots of 5 and 1. So the square roots of 5 will get plus and minus root 5. And so I'm going to go ahead and say what the y is. So one way you can think of it is if you plug it in, 5 times plus and minus root 5 squared plus y squared equals 30. Well, then plus or minus square root of 5 is just going to become 5. 5 times 5 is 25. So 25 plus y squared is equal to 30. We'll subtract 25. Y squared is equal to 5. And then we would take the square root, so the y would be, in fact, plus and minus square root of 5 also. then the x equals plus and minus 1. So we'd have 5 times plus and minus 1 squared plus y squared equals 30. So that'll be 5 plus y squared equals 30. So y squared is equal to 25. And when we take the square root of that, we're going to get plus and minus 5. Okay, so plus and minus 5. Okay, and so there's our ellipse, also known as a New England Patriots football. And then we got the reciprocal function, and we'll draw that in. And what we found were the 4 places where those intersected. So the intersections would be root 5, negative root 5, negative root 5. So, and then that would probably be this one and this one. And then 1, 5, and minus 1, 5. That would be this point and that point there. Okay, so they're a little bit different. They're not real bad. You just got to practice them a little bit.